Have you ever wondered what happens to rainwater once it soaks into the ground, seemingly vanishing beneath the surface? The soil is far from empty. It holds water in distinct ways, each crucial for the environment and plant life. Soil water exists primarily in three defined forms: hygroscopic water, capillary water, and gravitational water. Each form is categorized by how it is held within the soil matrix, directly influencing its availability to plants and its movement through the soil profile. Hygroscopic water is the thinnest film of water tightly bound to soil particles by strong adhesive forces. This water is held so strongly by the surface tension and electrostatic attraction to the mineral and organic matter in the soil that plants cannot absorb it. It is essentially unavailable to them. Capillary water, on the other hand, is held in the smaller pore spaces between soil particles by cohesive and adhesive forces, forming bridges between the particles. This water is largely available for plant uptake. Finally, gravitational water is the water that fills the larger pore spaces and moves freely downwards through the soil under the influence of gravity, eventually draining away to deeper layers or groundwater. Understanding these distinctions helps us grasp how water moves and is stored in soil. For plants, capillary water is the lifeline, while hygroscopic water represents a permanent wilting point if no other water is present. Gravitational water is temporary, quickly draining out, but it also recharges aquifers and can lead to leaching of nutrients. Farmers, for example, relying on understanding capillary water to optimize irrigation schedules, ensuring their crops have sufficient moisture without waterlogging the roots. These classifications are intrinsically linked to soil characteristics like texture and structure. For instance, clay soils, with their abundance of small particles and large surface area, can hold more hygroscopic and capillary water than sandy soils, which have larger particles and pore spaces. The concept of field capacity represents the amount of water a soil can hold against the pull of gravity after excess gravitational water has drained away. The permanent wilting point is when only hygroscopic water remains and plants can no longer extract enough moisture to survive. By comprehending the nature of hygroscopic, capillary, and gravitational water, we gain a deeper appreciation for the complex interplay between soil, water, and life. This knowledge is not just academic. It empowers better agricultural practices, informs land management decisions, and enhances our ability to manage our precious water resources more effectively for a thriving planet.
If you love learning about water, like, subscribe, and keep exploring with us.